Now here the question say that all possible 3-digit even numbers we have to form. The condition is that if 5 is used as one of the digit, then the next digit has to be 7, right? So there are two different ways wherein we can make the 3-digit even number. One wherein we are not using 5 at all, right? And the other case wherein we have to use 5. But if we are using 5, then the very next digit has to be 7. So let us solve this condition first, that the digit contains 5. So if this is a 3-digit number, definitely 5 cannot come here because it's a 3-digit number. So, and in fact it will not be an even number also, right? 5 cannot come at the tens place also, because if this is the 5, then this has to be 7, then this number will not be an even number. So the only place where 5 can appear is this, right? Here we can fix 5. So definitely here we have to fix 7. Now this place can be any even number out of 2, 4, 6, 8 and 0. So obviously the number of ways is 5. So we can say that there are 5 different numbers will be formed. Now let us take the next condition where we are not using digit 5 at all. Now if you are not using 5 digit at any of the places, then definitely this place will be 0, 2, 4, 6 and 8, so that to ensure that the numbers are formed is even. We can't use 5 here, now neither we can use 5 here, but we can use 7, right? Because using 7 has no condition for using 5, but if we are using 5, then definitely we have to use digit 7. So this place can be anything out of anything other than 0 or 5. So obviously the number of ways is 8. This place can be any 9 number including 7 in fact, right? This place has to be 5 place only, right? 5 ways. So the overall values for this is 360, as we can see. So the answer, total answer would be about 360 plus 5, which comes out to be 365. So that becomes our answer. Now here the question says that the number of 5-digit number which are divisible by 5 and each number containing the digit 5 and all the digits are different, they are in the form of k into 4 factorial. So we have to find the value of k. So let us find the total such numbers, and then we will just the final answer will tweak the answer which will be represented in this format, and finally we'll be calculating the value of k. Now here if the number has to be divisible by 5, clearly the last digit, this is the 5-digit number, the last digit has to be 5, right? Or it has to be 0. So let us take the case wherein the last digit is 5. Once this digit is fixed, no other digit will be 5 because we have to consider all digits to be different, right? So this place cannot be 0 because it will not be a 5-digit number. It cannot be 5 also. So definitely this place can be done in 8 ways. This place can be done in again 8 ways because now we can use 0. This place can be done in 6 ways and this place can be done in 7 ways. So clearly the answer for this part would be 8 into 8 into 7 into 6, right? Now let us take the next case wherein the last digit is fixed to be 0. Clearly we have to use one digit to be 5. That digit 5 can be either this, this, this or this, or we can say that any one place out of these 4. So selecting digit 5, place for digit 5 is can be done in 4C1 ways. Rest of the 3 places again will be applying the same logic, that it should start with or the options for the rest of the 3 cases. For example, let us assume that this is the place wherein we have fixed the digit 5. Then these 3 places can be done in 8 into 7 into 6 ways, right? And we have to multiply it with this so that all possible places for digit 5 can be considered. So the total answer will be this plus this. On addition, we'll be getting it as 168 into 4 factorial, right? If you do the addition of these two, take out the 4 factorial outside, then this will be in this particular format. So clearly on comparison, the value of k would be 168. So answer is 168. Now here the question says that the number of 6-digit number which we have to form using these 7 digits, so that digit is not repeating and the terminal digits are even. So when I say terminal digits are even, that means if I take the 6-digit number like 1, 2, 3, 4, 5 and 6, then this digit and this digit need to be an even number, correct? How many even numbers we have? We have this, this and this. So we have 3 even numbers. So we can fix this even number in these 2 places in 3C2 ways, right? This is selection of 2 even number out of the 3, and we have to arrange them also. We can arrange that whatever the even number comes here. For example, if I take 2 here and 6 here, the next what we can do is that we can swap them, and we can take that 6 is here and 2 is here. So for each selection there are 2 possible ways of arranging them. So this is how the even numbers will be fixed. Once these even numbers are fixed, then we are left with 5 numbers, correct? So those 5 numbers, out of those 5 numbers, we have to select 4 numbers and arrange them. that can be done in 5C4 into 4 factorial base. So we have to multiply this. So obviously this is 3 into 2. This is 5 into 4 factorial. So on calculation, we'll be getting it as 720, and that is the answer. Now in this question, we have to find the number of natural number which are between 1000 and 9999. That means a 4-digit number we have to find, so that they do not have all 4 different digits. So what we can do is that we can find the total number, right? And we have to divide it with those numbers wherein all digits are different. Correct? The total number of numbers, if I include both, then it has to be 9000. Correct? Now we have to find a 4-digit number with all the digit different. So obviously this can be done in 9 ways. This again can be done 9 ways. This in 8 ways, and this in 7 ways. So the total number of numbers is product of this, which comes out to be, this will be 81 into 8 into 7, which is 4536. So we have to take the difference of this. So we have to subtract it from 9000. So we'll be getting 4464. So this becomes the answer. Now here the question says that we have to find all the positive integers wherein no digit is repeating and the sum of digit has to be 45. Now if I take the digit, all the digit 1, 2, 3, 4, 5, 6, 7, 8 and 9, and if I add them, then it comes out to be 45. That means we have to take all the digit, or what we can take is that we can take only these digit, that is 9-digit number, or we can take 10-digit number which will have 0 as one of the digit. So if I take only 9-digit number, then the number of ways is 9 factorial. Correct? If I take the 10-digit number, then we have to take use 0 as well. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This number can't be 0. So obviously it has 9 possibility. Again, this has 9 possibilities. So this will be 8, 7, 6, 5, 4, 3, 2 and 1. So their product will comes out to be 9 into 9 factorial. So we have to add both of them, which comes out to be 10 factorial. So option 1 becomes the. Now here the question says that we have to find a 3-digit number wherein the 100th place digit is greater than the other 2 digits. So if I take these 3-digit number, then this digit has to be greater than the other 2 digits. One such number if I start, then if I fix the digit 9 here, then definitely these 2 digit has to be any number which is less than 9. So possibility for this number is anything from 0 to 8. Similarly from here also 0 to 8. So thereby we can say that it has 9 options. It has also 9 options. So the overall number has to be 9 into 9, which comes out to be 81. The same thing we can do when we fix the number to be 8. So thereby here it will be from 0 to 7. Here again 0 to 7. So the options would be 8 into 8, which is 64. So we can see here is that this is 9 square, this is 8 square. If we clearly extend this idea, then we can say that the answer should be 9 square plus 8 square plus 7 square, so and so forth till 2 square plus 1 square, which is nothing but 9 into 9 plus 1, that is 10, into 2 and 2 into 9 plus 1, that is 19, divided by 6. I'm applying the formula that 1 square plus 2 square plus 3 square, so and so forth till n square is nothing but n into n plus 1 into 2n plus 1 divided by 6. Here the value of n is 9. So on calculation we'll be getting it as 285, and that becomes the right answer. Now here the question says that we have to find the number of permutation of these 9 digits taken all at a time, such that digit 1 appears somewhere to the left of 2, 3 appears somewhere to the left of 4, and 5 appears somewhere to the left of 6. So here we can see that if I arrange, if I create any of the any such number, for example, one of the example given here is this. Here we can see that 1 is somewhere left of 2, 3 is somewhere left of 4, and 5 is somewhere left of 6. So if I ignore this condition, and if we just need to find the 9-digit number without repetition, then we can say that the overall value would be 9 factorial, right? But in this case, there will be half the chances wherein digit 1 will be left of 2 and half the chances where digit 2 will be left of 1, correct? So we can divide it by 2 factorial so that we can ignore this possibility, right? From the numbers left, again there will be half the chances wherein digit 3 is left of 4 or digit 4 is left of 3. Again we have to rule out this possibility, so again we'll be dividing it by 2 factorial. The same logic we'll be using for 5 somewhere to the left of 6. So again we'll be dividing it by 2 factorial. So on calculation it's simply 9 into 7 factorial. So option 1 becomes the right answer. Now in this question it says that there is a committee of 8 persons, and out of which we have to choose a chairman and a vice chairman, and no one can hold both the position. So it's a very easy question. Straight away we can say that for a chairman the number of options is 8, right? And for the vice chairman we'll have only 7 options, because once the chairman is selected, definitely he will not be available for the post of vice chairman. and these two can be done in 8 into 7 ways, which is 56. So 56 becomes the answer of this. Now here the question says that we have to find the number of ways wherein 6 different books that can be distributed among 10 people if each person can get at most one book. That means nobody will be getting more than one book, right? A person can get may get 0 book or 1 book at max. Now for doing this particular exercise, what we should be doing is that first of all we should select that which 5 people will be getting those 5 books. So the selection would be 10C5. Once the selection is done, for each selection the number of ways when these 5 books can be distributed would be 5 factorial. So multiplying them would get me the answer. Straight away option 4 becomes the right answer. Now in this question, you have to say that a student has to answer 10 out of 13 questions in an examination. The number of ways where he can answer it such that he must answer at least 3 of the first 5 questions. So if we can divide the question paper in a set of 5 questions and rest of the 8 questions, then from the 5 he has to choose at least 3. That means he can choose more than 3 also. So if he choose 3 from the first 5, then the number of ways is 5C3, right? Since he has to answer 10 questions, then 7 questions must be selected from the other 8 questions. So obviously it can be done in 8C7 ways, and together that can be done in this way. Next case is that he is selecting 4 questions from the first 5. Then it can be done in CC4, 5C4, and rest of the question will be from the next 8 question. And if he select all the 5 questions from the first 5, then he has to select 5 questions from the rest of the 8 questions. So we have to add these 3 numbers. On addition, we'll be getting it as 276, and that becomes the right answer.